So this topic is for those in JSS 3, those who are preparing for their basic education certificate examination. So this is just a revision of what we did in the second term of JSS 3. The topic we are going to treat today is simultaneous equation. It's a very interesting topic for students of JSS 3, and we are going to look at the method, the simultaneous equation. There are three methods that can be used in solving simultaneous equation. Now, every equation in mathematics must end with a sign of equality. That's how we know equation. But in this kind of equation, unlike the linear equations and quadratic expressions and all that, this one is simultaneous equation. It's solving two linear equations at the same time. So that is about simultaneous equation. We have three methods of solving simultaneous equation. Number one, we have substitution method. Substitution method. Then number two, we have elimination method. Elimination method. Then the third one, we have a graphical method. Graphical method. So these are the three methods of solving simultaneous equation. But in this talk today, we are going to limit ourselves to the two: substitution and elimination. Graphical method will be maybe for those in the senior classes, those taking their way. But we are limited to, due to the scheme of work, substitution and elimination. So we'll move to the substitution method. We are going to use examples in solving them. The substitution method, we have one problem. Example, we have A. Example 1, x plus 1 is equal to y. And then we have x plus y is equal to 3. First of all, before this is a substitution method. Using the method of substitution, we call this one equation 1, and we call this one equation 2. In substitution, the aim is to make one variable the subject of the formula. For instance, here in equation 1, we have x plus 1 is equal to y. So in other words, we can say y is equal to x plus 1. The same equation 1. They are just the same thing, just because change of position. Y is equal to x plus 1. Now, what you do now is to substitute this y equals to x plus 1. Anywhere you see y, you substitute it with x plus 1. So we say substitute substitute y is equal to x plus 1 in 3, in equation 2, in equation 2. So you are going to substitute this y plus y equals to x plus 1, which is equation 1. Substitute it in equation 2. Now it goes like this. Equation 2 is x plus y is equal to 3. Now in doing the substitution, what we mean is that this y now will be replaced with x plus 1. So you say x plus, instead of you to write y, you write x plus y, which is the equivalent value of y in equation 1, which is equal to 3. So this is equation 2. And the only change we made in this equation 2 is to substitute. We have substituted the value of y in equation 1. And that's why you have x plus 1. Then you open the bracket. X plus y is equal to 3. Now with this, you collect like terms. This one will cross over the sign of equality. So we have x plus x is equal to 3 minus 1. So x plus x is 2x is equal to 3 minus 1 is 2. So dividing both sides by x. Divide both sides by the coefficient of x, which is 2. So we have now 2x over 2 equals to 2 over 2. So our x is equal to 1. So you see, we have got x, but now we are going to find y. So having gotten x, which is equals to x equals to 1, then we say substitute s equal to 1 in any of the equation. You can use also equation 1 in equation 1. And equation 1 already we have it that x plus 1 is equal to y. So our x is 1. So our x is 1. So you say 1 plus 1 is equal to y is equal to y. So therefore y is equal to 2. So and then our x equals to what? 1. So this is the solution of this simultaneous equation. S equal to 1 and y is equal to 2 because 1 plus 1 is 2. So you can also check. Normally in every simultaneous equation, you can always check to verify whether the answers you got are correct. X equals to 1, 1 plus 1, and y is equal to 2 is equal to 2. So the equation is the answer it is correct. Then also x equals to 1 plus y equals to 2 equals to 3. So that is using substitution method in solving simultaneous equation. Now we are going to use the elimination method. The elimination method is very interesting. In fact, that is the method I employ always. It's very interesting, very simple. So elimination method. Normally you can use elimination method in solving every simultaneous equation, but using substitution method can be difficult in some, especially for instance in questions like this. 2x plus 3y is equal to 29. 3x plus 2y is equal to 16. Here we can use substitution method in solving this, but it will be very difficult somehow and elaborate. So the best method you can employ in solving this kind of simultaneous equation is elimination method. And first of all, you call this is equation 1 and this is equation 2. So how do you go about the elimination? It depends on you. Just decide which variable. You can decide to eliminate y, you can decide to eliminate x, or you eliminate y. But whichever variable you want to eliminate, what you should target at is to make both the coefficient of the variable you want to eliminate to be the same on both equation 1 and in other words, they are not the same here. Here x is 2, the coefficient of x is 2, the coefficient of x here is 3, so they are not the same. So you have to make them the same, and when you make them the same, you form another equation 3 and 4. How do you make this the same? Think about it. Let me say to eliminate x, we want to eliminate x, so we want to make x here and here to be the same, the coefficient of x to be the same on both sides. What do we do? Looking at it here, and in mathematics, when you tamper with any variable in an equation, it must at any time in an equation, it must affect all the terms in that equation in order to maintain the sign of equality. So now think about it. We want to eliminate x. So if we multiply 3 by 2, you get 6, and multiply 2 by 3, you get 6. So multiply 3 by 2 to these 2 will give us 6, and multiplying 2 with this 3 will give us 6. So it means that 3 times we multiply everything here in order to still maintain that equation, and also 2 we multiply everything here to maintain the balance of the equation. But the aim, our target is to make, in other words, at the end of the day, we are going to make the coefficient of x in this equation and the coefficient of x here to be the same. Now to eliminate that, you say, well, to eliminate x, 3 times equation 1. 3 times the whole of equation 1. So we begin 3 times 2x, we have 6x plus 3 times this, 9y is equal to 3 times 29. We have 3 times 29, we have 87. So you see 87. Now in the second equation, we say 2 times equation 2. 2 times 3x, we have 6x. Now, you see, our target is reached. We have 6x here, 6x here. That is our target. Now, we have 2 times 4, 2x, 2y. We have 4y. It's equal to 2 times this. We have 32. This you call it equation 3, and this you call it equation 4. So, this is where we are told we are going to do the proper elimination. Now, what do you do? To know whether you are going to, normally, if you want to, you are going to do minus or to add. You are going to do subtraction or addition in order to eliminate. When the signs, considering the term that we want to eliminate, here, we want to eliminate x. So, the coefficient of x here and the coefficient, the signs are the same. When the signs are the same, you subtract. But when the signs are not the same, when in the case of here is plus or here is minus, you add in order to eliminate this x. So the signs are the same here, so we subtract. So what do we say? We say 3, equation 3 minus equation 4. Equation 3 minus equation 4. So that means 6x minus 6x, we have 0. So we have cancelled down this x. So now we have 9y plus 9y minus 4y. We have 5y, which is equal to 87 minus 32. 87 minus 32 will give us 55. So we have now 5y is equal to 55. So at this, then we now find y. So we continue. 5y is equal to 55. Therefore, dividing both sides by 5, y is equal to 55 over 5, and that will give you 11. So y is equal to 11. So that is the answer. So if y now is equal to 11, then you have to find x. You say substitute y equal to 11 in any of the equation. In 1, 2, say in 1. So 2x plus 3y is equal to 29. So what you do is wherever you find y now, you substitute it with 11 to get x. 2x plus 3 bracket 11 is equal to 29. So 2x plus 3 times 11, 33 equals to 29. And then finally, we have 2x is equal to 33 minus 29. This 33 crosses the sign of equality becomes minus 33. 2x equals to minus 4. So 29 minus 33 is minus 4. So now our x now equal to minus 4 all over 2. And that will give us minus 2. So therefore, x is equal to minus 2 and y is equal to 11. So this is our answer for this. So you can also verify your answer by inserting the appropriate values of x and y. So our x is minus 2. So 2 times minus 2 is minus 4. Plus 3 times 11 is 33. So minus 4 plus 11 plus 33 will give you 29. Verifying also this one, x is minus. We are going to the next topic we are going to treat, review is of variation. Variation, as we did, the relationship between quantities. The relationship between quantities. And there are 4 types of variation which we treated. The first one, we have the direct variation. Direct variation. Then the second one, we have the inverse variation. The inverse variation. Then the third one, we have joint variation. And the fourth one, we have partial variation. And these variations have their formula. The first one, direct variation. Normally it is direct. When a quantity, let's take for instance the price of a commodity to the quantity. If I want to buy 5 balls, 5 football balls, maybe one football ball is sold at 1,000 naira, and I want to buy 5. So you see, the number of the football ball I'm going to buy will also increase with the price. So that is an example of direct variation. This one increases and this one also increases. Let's take for example, we use something like P varies X. We normally use that for direct variation. P varies X. So we'll talk about P. When P varies X, the formula says this is the symbol of variation. P varies X, meaning P is increasing and also X is increasing. In order to make this into a formula, we say P is equal to Kx. Therefore, K is equal to P over X. So that whenever I want to find K, which is K is the constant. Want to find K, you must find, before ever you solve any problem of variation, you must find the constant. So K is the constant, and this K, which is the constant, once you find K, which is the constant, you can then find another. This is such a review. Then the second part of variation is inverse variation. Inverse variation. In this type of variation, one variable, one quantity increases, the other decreases. Let's take for instance, if 5 persons we are told to sweep this class, if it will take 1 person to sweep this class 5 minutes, maybe 10 minutes for 1 person to sweep this class. If you increase the number of persons to sweep this class, you discover that the time it will take them will be lesser. So that is an example of inverse variation. Increase in the one quantity, decrease in the other one, then decrease in the other quantity, increase in the other quantity. That's what we call it inverse variation. And using P and X. In inverse variation, we say P varies 1 over X. So this is how we know inverse variation. And then for putting this into an equation, P is equal to K over X. Then therefore your K will be equal to Px. So this is the formula. So for you to find to solve any problem on inverse variation, you must find K. And how do you find K? P times X. That is, this P and X represent unknown variables. It could be quantity of something or anything with regard to the equation. We are just doing a kind of review. Then the third kind of variation, we have joint variation. Joint variation. In this type of variation, we have 2 types of joint variation. It could be, this is joining the direct and inverse. Next thing, for instance, it could be, you have to bring in another quantity, 2 quantities relating with 1, that is joint. So let me say P relating with X and T. So we can say joint variation, we have the first aspect of it is you can say P varies XT. So P varies directly to 2 quantities, XT. So this is an example of that. So finding K here now, we say P is equal to, you can say P is equal to KST. Therefore, our K now will be P over ST. This is the first type of joint variation. Then the second type of joint variation, we can say P varies directly with X and indirectly with T. So this is another type of joint variation. So in this one, you say P now will be equal to KX over T. And then your K will be equal to PT all over X. So this is just a kind of review. I know my students out there, we have done this in the classroom, just doing a review of what we did and second term. So this is joint variation. Then the final type of variation is what we call the partial variation. The partial variation. Number 4, partial variation. And in partial variation, this partial variation will lead you, in this partial variation, we have 2 constants. And here it will lead us to simultaneous equation. So that is in fact, this partial variation, I think that is the end of any variation in JS3, because at the end of the day you find yourself back to simultaneous equation. So for you to have studied variation, you must have done simultaneous equation, taken for granted. Then we use instances. I've used questions on your past questions, which are past questions of those in JS3 who were in JS3 last year. Now the first question here, we said B. This is the example. This example, we are going to use it to, is part of the example on the last part of variation, which is partial variation. We said E is partly constant and partly varies with A. E is equal to 30 when A equals to 12, and E equals to 54 when A equals to 20. Then the question says, find the formula connecting E and A. Then hence find E and E when A equals to 27. First and foremost, you are going to form the equation. These are, just as I said, partial variation is simultaneous equation. So you form the equation. You say E is equal to, is partly constant. E is equal to C plus partly varies with A, K, A. That's how to form. So with this now, you represent the first equation. So what is E? In the first equation, say E is equal to 30. So you put 30 is equal to constant C, we don't know it, plus what A is 12. So 12K. So definitely we have to so we have now C plus 12K is equal to 30, and this will be our equation 1. This is our equation 1. Then the second aspect of it is, as we said, E is 54 when A is equals to 30 is equals to 20. So we put it 54 is equal to C plus A is 20K, and then arranging the equation where we have C plus 20K is equal to 54, equation 2. So you see equation 1 and equation 2. So with this we can use the method of elimination. So we bring down both equations. Now we have C plus 12K equals to 30, equation 1. C plus 20K equals to 54, equation 2. So here now already we have C. Two equations, the equation 1 and equation 2, they have the C, the constant is, the coefficient of the constant is the same. So we can easily, using the method of elimination, we can easily eliminate C. So since C and C are the same, we have the same coefficient, what we do is say we do minus. This is minus in order to eliminate C. So we say equation, because we have greater number here, we can say 2 minus 1. Equation 2 minus equation 1. You can also say equation 1 minus equation, but only know that it will end in minus sign. But at the end of the day, it will reverse it. But I think the easier way is to eliminate 2 to 1. So 2 minus equation 1. Of course, C minus C is 0 already. So we have 20K minus 12K. 20K minus 12K will give you 8K is equal to 54 minus 30 is 24. So you see 8K is equal to 24. So our 8 now will be equal to, our K is equal to 24 over 8, which equals to 3. So K is equal to 3 from what we have solved. So we have gotten K as equal to 3. So what we do now is substitute as we used to do it in elimination. K equals to 3 in any of the equation, either equation 1. So it says sub k equal to 3 in equation 1. What is our equation 1? C plus 12k equal to 30. So it says C plus 12. Instead of writing k, write bracket 3 is equal to 30. K plus 12 times this will give you 36 equals to 30. So our k now equals to 30. This 36 crossing the sign of equality will be minus 36. So our C now equal to 30 minus 36 will give you minus 6. So our k is minus 6. That's from what we have solved here. Our k is what? Minus 6. So our C is minus 6. Our k is 3. So the question says, the first question says, it says find the formula connecting E and A. So finding the formula connecting E and A, the formula we have is E is equal to C plus KA. That's the formula. So we have to put the number now. We have to replace C and K with the number. So we have now E is equal to, what is C? From what we have solved, C is minus 6. So minus 6 plus, what is our K? Our K is 3A. So this is the formula connecting E and A. So the second one says find E when A is 27. Find E when A is, so E is equal to, if A is 27, find E. So E equals to minus 6 plus 3 bracket 27. So minus 6 plus 3 times 27 will give you 81. Minus 6 plus 87, of course, will give you 75. So 75 is the answer of E. I think that is all. So I will give you assignments I want my students in JS3 to do with regard to the simultaneous equation and the variation we treated today. The first one, number 1, solve the following. 3x plus 2y is equal to 12. And then 5x minus 3y is equal to 1. So you solve this is number 1. Then number 2, on variation. T varies directly with W and inversely with P. When W is equal to 7 and P is equal to 3, T is equal to 42. I find the relation between T, W, and P. I find T when W is equal to 5 and P is equal to 9. So I would like you to solve this, and also you write it and send it to my private chat through the WhatsApp. Thank you. This will come to the end of the revision of second term for those in JS3. I think the next topic we should be treating is on construction. Well, you know, this construction, we will have to, let's pray that the lockdown will be called off, so that we come back and do this. It's more of practical. It's not something you send online, because it's a practical aspect. I have to watch you people do it so as to help you to understand the construction. So I wish you, we are missing you guys there at home. So try as much as you can to read and prepare well. We are proud of you, and we know that you are making us proud there. So God bless you. I remain your teacher, mathematics teacher. Bye.